Welcome to video 1.1a, Classifying Matter. In this video, you should be able to define element, define compound, compare pure substances and mixtures, differentiate between homogeneous and heterogeneous mixtures, and identify diatomic elements. When we classify matter by composition, we generally break them up into two major categories, pure substances and mixtures. We're going to start by talking about pure substances. Pure substances are substances that are 100% pure. And what I mean by that is if you buy a pure substance in the United States, or you buy a pure substance in Africa or Japan, or Australia, you will always get exactly the same substance. Pure substances are not mixtures. We break pure substances down into two main categories. They are elements and compounds. Let's start with elements. On your periodic table, in your reference tables, you have a list. The periodic table is basically a table of all the elements that are available to you. They are the simplest building blocks of matter. They are a list of the elements. We can talk about an atom of each particular element. The atom is the single unit where the element refers to all of the like types of atoms. For instance, carbon is an element. We can talk about an atom of carbon, but carbon, when I refer to the word carbon, I'm talking about all of the carbon atoms, and we talk about that in terms of carbon being an element. If I buy carbon in the United States, I will get the same thing as if I buy carbon in Australia. Compounds are two or more of these elements that are chemically combined. Compounds always have their elements in what we call a fixed ratio. In the law of definite proportions states that we will always have the same number of each element in a particular compound. For instance, water is a compound. Water consists of hydrogens and oxygens. There happens to be 2 hydrogens in every water molecule, and there's 1 oxygen in every water molecule. There's no 1 written down there. The numbers that are written in the lower right-hand corner of the elements are called subscripts. We don't generally write 1 as a subscript. So if I wanted to go and buy water in the United States, I would buy 2 hydrogens and 1 oxygen, and I would get 1 molecule of water. If I went to Japan and I asked for water, I would get 2 hydrogens and 1 oxygen. These hydrogens and oxygens are chemically combined. They will always be in a ratio of 2 to 1. If, however, somebody handed me H2O2, that is not water. This is hydrogen peroxide, a totally different substance. Compounds are pure substances because if I take a sample of water, I will always get a ratio of 2 hydrogens to 1 oxygen. Take this time now to write these things in your interactive notebook. Elements are the simplest building blocks of matter. They are composed of a single type of atom. Compounds are 2 or more elements that are chemically combined. Those elements will always be in a fixed ratio. The other subcategory of matter is called a mixture. Mixtures are not pure substances. They are mixtures of two or more pure substances that are not chemically combined. Mixtures can be subdivided into two other categories, heterogeneous and homogeneous. Let's start with the heterogeneous mixture. Heterogeneous mixtures include things where when you are looking at the mixture, you can actually see the individual parts. My example is a tossed salad. You have a tossed salad which has tomatoes and cucumbers and onions and lettuce. You can see each of the individual parts, and you would be able to pick what part of the salad that you would like to eat. Would you like to eat a tomato or a cucumber? When we have a heterogeneous mixtures are very easy to separate. You can filter them, or you can just separate them by hand. When we deal with homogeneous mixtures, over here, homogeneous mixtures are a little bit different. Homogeneous mixtures appear uniform throughout. In other words, when you look at a homogeneous mixture, you may not see the individual parts that are making up the mixture. An example would be salt water. When you look at salt water, you will not see the salt separate from the water. You would not be able to pick out the salt separate from the water. These are generally clear, and we have a special name for them in chemistry called a solution. Solutions are homogeneous mixtures. When we write homogeneous mixtures formulas, we have a little symbol that we write after the formula. That symbol is AQ. AQ means mixed with water. So in this case, I have NaCl, which is sodium chloride, salt, table salt, mixed with water. When you see this AQ, it's automatically a mixture. Most of the time, when you have an AQ after it, it is a homogeneous mixture. Take the time now to write these definitions in your interactive notebook. Heterogeneous mixtures are two or more substances that are not uniformly distributed. Heterogeneous mixtures can be separated by filtration. If you take a heterogeneous mixture and send it through a filter, the solid will stay on the top and the liquids will go through the filter. You can also sift it, like when you were a toddler at the beach and you had those sifters, and you get the big rocks that stay in the sifter and the sand goes through. Heterogeneous mixtures can be separated by filtration. Homogeneous mixtures are uniform throughout. These mixtures cannot be separated by filtration. They are called solutions. So we need to use different techniques to separate homogeneous mixtures. There's a couple different techniques for separating solutions or homogeneous mixtures, and we're going to look at the chromatography first, which is up here in the upper left-hand corner. Chromatography separates mixtures according to their mass. The lighter the substance that you're trying to separate out, the further it will travel. Usually there's water or alcohol that is the vehicle that is being used to move the particle up through the chromatography paper. So if you look right here, let me get a pointer out. I'll get a green one. If we look right here, the mixture that we're trying to separate, in this case it was ink, if we put the ink dot down here, the ink will start to travel up the paper and the heavier inks will start to come out, and then the lighter inks will travel further and further. And then you can see the different colors that make up the black ink. Chromatography is used to separate DNA and also inks and other assorted solutions. There's also something called fractional distillation. This picture is not the best, but I hope you get the idea. With fractional distillation, you're separating a homogeneous mixture according to boiling points. Very important. Fractional distillation will separate a mixture according to boiling points. If the mixture is in this particular vessel right here, and we want the mixture to separate, the mixture is heated up, and as the temperature rises, the different temperatures or the different particles that are within this vessel, the parts of the mixture will separate according to their boiling points. Another example of distillation is right down here in the bottom left-hand corner of your screen. I'll make it a little bit bigger. This one uses a distillation tube, which is right here under the pointer. It uses a distillation flask, which is right here. The component or the mixture that you want to separate is down here at the bottom, and as you heat it up, the water or the liquid, or if there's two liquids in here, the liquid with the lower boiling point is going to vaporize first. When it vaporizes, it travels up here as a gas. It vaporizes, and then it starts to travel down this tube. When it reaches that tube, the water that is in this flask or this tube, it's called distillation tube, condenses the vapor, and the vapor turns back into a liquid, and it collects over here in this collection vessel, which happens to be a flask. It could be a beaker, it could be anything. Distillation flasks are fairly easy to use. They usually only separate mixtures that have two components, very simple, not like fractional distillation where you have many components with different boiling points. Here, if we had salt and water, the water would vaporize, it would turn into a gas, would travel up into here as a gas, okay, H2O gas. It would travel down this tube, condense in here, and pure water would be collected over here. What would be left would be the salt, because the salt will not vaporize, will not turn into a gas until it reaches over 800 degrees. Okay, here we have the entire picture, so you can see how matter is classified and broken down into its subcategories. Matter is broken down into mixtures and pure substances. Mixtures can then further be broken down into heterogeneous and homogeneous. If it's a heterogeneous mixture, we can call it a suspension. If it's a homogeneous mixture, it is called a solution. And keep in mind that you have this little AQ that is written after, and that AQ represents that you are talking about a solution or a mixture. Pure substances are broken down into elements and compounds. Compounds and elements. Elements are atoms. Atom is one unit of the particular element, and compounds are molecules or salts. Sorry, I had to let the dog go, who just went and attacked somebody at the front door. So, good luck to them. Okay, so now we've got molecules, which we'll talk about the definition of molecule later on in the year, and we have atoms. Keep in mind that you will recognize an element by looking at your periodic table. If it is on the periodic table, and use table S to your advantage with all the names, if it is on table S, then it is a pure element. Oh, once again, take this opportunity to write the definition of atom in your interactive notebook on page 11. A single unit of an element is an atom. It's the simplest building block of matter. Compounds are two or more elements chemically combined, and you're going to recognize a compound because a compound must have two or more capital letters in its formula. That's why it's very important that we use capitals and lowercase to designate our elements. Here you can see that I used sodium with a capital N and a lowercase a, and chlorine with a capital C and a lowercase l. Okay, the last thing we need to talk about is something called a diatomic element. Diatomic elements are when two identical atoms are chemically combined or bonded together. There are 7 diatomic elements, and you must commit these to memory. We use the acronym Brinkelhoff so that we can remember them. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Brinkelhoff. You can also use your periodic table, and since there are 7 diatomic molecules, you can see that they make the shape of a 7, starting with atomic number 7, nitrogen, make the shape of a 7 and go all the way down to iodine. Now that only gives you 6 out of the 7 diatomic elements, so you must remember that the 7th one is hydrogen, and it's all the way over here by his little old lonesome self. Okay, I hope this video helped. Until next time, if you need any help, let me know.